Hello, everyone. Ah, how's everybody doing? Oh, we don't have too many people here yet. I had to update Zoom before I was able to join. I wonder if others are in the process of doing that. I'm good too. Yeah, a little tired out, but I can't believe we're already on week 4. Yeah. Okay. Um, so today, we're going to be talking about identity theory. Um, This is, I think, probably a little bit of a more straightforward chapter than the last one. In any case, I like this chapter. And then, of course, next time we're going to talk about the instructions for your essay assignments. Before anyone asks, uh, I have not exactly started marking the first reflection assignment yet because quite a few people reached out for an extension, which is okay. I'm glad that people felt, you know, I'm glad that people weren't shy about requesting extra time if that time was needed. Um, so, for those of you that got it submitted on time, thank you. For those of you who were sick or had technical difficulties or other extenuating circumstances and you let me know, thank you. Um, it's good that you feel that you can do that, right? And like I said, I tend to be pretty accommodating. Um, I haven't looked at those. I'm kind of waiting for a few more to trickle in, and then Jack and I are going to get started. And then we're going to hopefully have those done. Well, not hopefully. We're going to aim to get those marked and have those grades returned to you before the essay proposal is due, which is actually on June 5th. So that's about 2 weeks. Yeah, no problem. I mean, I get it. Like it's a busy time. You think it's the summer, like, oh, summer, easy. Um, well, summer courses are very compressed, and I know that many of you are taking more than one. Yeah, yeah. Grant, I don't understand what Feigl meant when he says that the mental is holistic. His comparison in that the table was that the physical is made of atoms. I don't know if you're going to cover this. Probably not, because Feigel's paper was background, and Kim doesn't actually discuss Feigl all that much. Um, I think he refers to his nomological danglers, which is a funny term. But I'll tell you what nomological danglers are when we get to that in the lecture. But Kim is actually more focused on smart for this reading. But if you found that background helpful, great. I can, of course, go back and take a look at what Feigl says in that paper. I actually haven't read that paper in about a year. So, um, okay. Well, I'm glad that you took a look, Grant. If you want, what I was going to say is if you want, I can take another peek at that paper. We could hash out whatever you're wondering about on the Discord server, if that sounds like it would be beneficial to you and to other people. And don't be afraid to remind me to do this, because I'm also super busy. Like Shannon's taking 4 courses. That's a lot. Um, so don't be afraid to remind me. Okay, so um, I think it's pretty uncontroversial to say that nowadays a lot of us would associate the mind with the brain. Here's a picture of a brain I found on the Wikipedia Commons. This particular brain, was removed from a cadaver during an autopsy, which is why I guess it looks a bit gross. But this is the brain. You can actually see, look, we have lots of little blood vessels here. You can actually see the different lobes on this brain. This right here is the frontal lobe. So this is the part of the brain that's kind of toward, well, toward the front, as the name implies. We have all sorts of important functions associated with this area, like executive functioning, um, our higher reasoning, decision making, planning for the future, um, planning out like various possible scenarios that might take place in the future. Lots of cool stuff going on there. Of course, we have our all of our frontal areas like the dorsolateral prefrontal cortex, the medioventral prefrontal cortex. They're all up in this area. And as we get further back toward the parietal lobe, which is right here, we get things like the premotor area, the motor cortex, the sensory motor areas are basically kind of in this sort of frontal parietal region. This bit here is the temporal lobe. This is associated with things like memory, and also things like hearing. And you can't really see in this picture, but on the back of the brain, on the posterior, that's our occipital cortex, and that's where vision happens. That's important for vision. Of course, a lot of these functions I've mentioned are actually not that precisely localized within the brain. Vision, for example, we have very interestingly a dual sort of pathway for vision. So once information from the optic nerves reaches your visual cortex, there's two pathways it can take. It can take a pathway up here. This is the dorsal pathway. This is what we call vision for action. This is unconscious visual processing, which guides motor action, like reaching out and grasping things. Then we have another pathway that comes down here to the temporal area, and that's vision for perception, looking at things and identifying them. Like I look at this coffee cup, and I go, "Oh, that's my coffee cup." Well, that's my ventral pathway that's responsible for that. But reaching out and picking up the coffee cup, that's thanks to the dorsal pathway. So, um, things are kind of distributed. It's not neat. The brain is beautiful and complicated and also messy, if you like. So, again, pretty uncontroversial to claim that a lot of us would associate the mind with the brain. But as Kim tells us, it certainly wasn't always this way. In fact, the ancient Egyptians did not really know what the brain was for. So when they mummified people, um, they removed organs during the mummification process, and they would place important organs in these jars. They're called canoptic jars. And if it was somebody really important, like the pharaoh, the idea was that the pharaoh needs all of his stuff in the afterlife. So not just his chariot and all his wealth and all his worldly possessions, but also his body and his organs. So they'd save everything important, like the liver or the kidneys. What did they do with the brain? Well, they just got rid of it because they didn't know what it did. So the brain was actually not preserved in these canoptic jars because they thought, well, maybe Pharaoh, well, he doesn't really need the brain in the afterlife. So either they didn't really know what it did, or perhaps they didn't think of it as the seat of the soul. Um, the ancient Greeks also weren't quite sure what to do with the brain. Aristotle, in De I believe, describes the brain as functioning like a cooling device, almost like a regulator of temperature. Um, but I suspect that the Greeks might have had some idea, certain of the Greeks might have had some idea that the brain was important because throughout human history, we have noticed that when people suffer certain injuries to the head, um, different functions of the soul, if you like, would change, right? This really started to change in the early modern period. So starting from Descartes, who thought that maybe the pineal gland, which is in the brain, was where the soul interacted with the body. We started to get some idea maybe the brain was important. And also, this was around the time that firearms started to proliferate. And what would often happen is that people from the earliest firearms all the way up to the First World War, some unfortunate people would actually be shot in the head and survive. Um, and this is how early neuroscientists learned about what areas of the brain were associated with which functions. So we started to see the importance of the brain. You've also got, of course, famously Phineas Gage, right? Remember, we talked about Phineas Gage, I believe, in an earlier lecture. He was the railway foreman who was tamping down some explosives into a hole, and the explosives ignited, and his tamping iron shot up through his brain. It went through the skull, like through here, up out the top, and basically went through his frontal cortex. And people report that, his friends, for example, and his coworkers reported that Gage's personality changed after his injury. Um, and this is probably because of the areas of the brain that were damaged. Um, although we gradually got the idea. It was widely believed in depending on the culture that the seat of the soul or the mind was not the brain, but some other organ. Commonly, in the so-called West, that would have been the heart. Likewise, in the Middle East. So the heart was sort of associated as the seat of at least the emotions. Although in some cultures, you also have this association with the gut, which I think is very interesting. So, where I always thought this was an interesting sort of cultural difference. Um, in medieval Europe, you could describe somebody who's generous as having a big heart. Well, you still could now, right? You can say, "Oh, this guy is very kind. He has a big heart." In medieval Japan, they would say of the same sort of person that he has a big belly because the viscera were the seat of the emotions. Incidentally, this is why samurai would commit seppuku. One of the reasons why they went for the gut and not the heart, because that's where uh, the soul might be in your viscera, your guts, rather than your heart. So sorry, I know that's a kind of a morbid example, but it just shows you that across human cultures, it took us a while to realize the importance of the brain. Often people in various cultures throughout history associated the brain with, or associated some other organ as the seat of the soul. Incidentally, for the Greeks, you've got the heart and the guts. You've got the heart in medieval Europe. You've got the guts in, I don't know, medieval Japan, right? You see the idea. But it turns out the brain is what is associated in some important way with the mind. Uh, Today, we're going to look at a theory that says that the mind just is the brain. And that's what identity theory is ultimately. It identifies the mental with the physical. It identifies them in the sense that it says that they are the same thing. So the mind just is the brain. Mental states are identical with brain states, right? So that's identity theory. So we figured this out. We know, like, that there are important correlations between the mental and the physical, between the mind and the brain, thanks to some of those brain injuries I described earlier, um, but also things like anesthesia or mind-altering drugs. Um, we can make people unconscious by giving them propofol, for example, such that we can perform surgery on them. If you have a headache, you can take aspirin, and hopefully your headache will go away. And that's because of the ingredients in the aspirin having an effect in your central nervous system, right? Or I can drink caffeine, which I drink a lot of, probably too much. And I think I forget which receptors those caffeine molecules are working on. I think it's like adenosine and norepinephrine and stuff like that. Maybe dopamine too, a little bit. Although dopamine's kind of always doing something because of the role it plays in our pleasure reward system. But you get the idea. Even those of you who believe in the soul, like a dualist sort of picture of the soul, I suspect that even you would say that there's an important role um, that the brain plays in um, in our mental lives. Even if what we really are is a soul of some sort, like an immortal soul, the brain is still important, right? Okay, any questions so far? We haven't really gone too deep into the material yet, but all right. Well, in that case, maybe we'll just carry on. Kim says it's plausible that everything that occurs in our mental life has a state of the brain or the central nervous system as its proximate physical basis. So its sort of immediate physical basis is of anything mental is some sort of activity in the brain and central nervous system. And so Kim formulates the mind brain correlation thesis. Let's read that thesis. What does it say? It says for each type M of mental event that occurs to an organism O, there exists a brain state of kind B, which we can call M's neural correlate or substrate, such that M occurs to O at time t if and only if B occurs to O at t. So again, that's a highly abstract way of putting it. Let's try and make it a little more concrete. So there are mental events that occur to organisms. So I'll be O. I will be organism O. And there are types of mental events that occur, like I don't know, being in pain. Let's use that as an example. Um, Now, if I'm in pain, if I'm the O that is in M, there must be another sort of physical state of kind B, a brain state, a neural substrate, a neural correlate, such that pain only occurs to me if B occurs to me at the same time. So, in order for me to be in pain, the neural substrate of pain has to be occurring at the same time that I am experiencing pain. My C fibers and my A delta fibers, namely, which are special types of neurons that fire um, when we suffer tissue damage. This is kind of apropos of all of this. I cut my thumb making some French fries last night, and now I'm just thinking like, oh, it still hurts a bit when I touch it. So I've got this mental state of a little pain in my thumb. Now I can only be in that mental state at this time because at the same time there is a brain state that's being realized. There's a neural substrate to my mental state, and that's my C fibers and my A delta fibers firing. And these are correlations. I think it's important to note these are correlations, okay? Kim has a lot to say about different kinds of correlations here because we all know, I hope we all know, you cannot just um, assume because there's a correlation, there is a causal relationship, right? So, before we talk about different sorts of correlations, are there any questions about the mind brain correlation thesis? Okay, I'm going to hop over to my web browser for a minute to find this gem. I should have put this in my slides. I always forget. Let's see. Nicolas Cage movies and drowning. Oh, misspelled it. Ah, here we go. From National Geographic. We have to be careful with correlations and trying to infer causal relationships. Yeah, Grant. I know it is wild, right? Let's go here to the full image. Whoopsie daisy. Oh, oh, okay. I guess I have to. I don't. I'm not. I don't have time to join National Geographic, but we can see here on my screen. You can see the number of drownings seems to be correlated with films where the release of films where Nicolas Cage appeared in. Now, does that mean that Nicolas Cage films cause drowning? No, of course it doesn't. Um, so, what can we say about mind brain correlations? Yeah, we've got to do something about Nicolas Cage. No, actually, it's fine because unlike Nicolas Cage movies and drownings, mind brain correlations are law like. So, as Kim says on page 92, the fact that pain is experienced when certain of your neurons, like C fibers and A delta fibers, are activated is a matter of lawful regularity, not accidental or coincidental co occurrences, like drownings and like the number of drownings and movies in which Nicolas Cage appears. And secondly, even the smallest change, Kim says, in our mental lives cannot occur unless there's a specific, perhaps as yet unknown, but nonetheless a specific change in the brain state. Like if your headache goes away, um, so you have a headache, you take something, it goes away. There must be an appropriate change in your neural states, which we can assume is the active ingredient in your aspirin. What is it? It's some kind of acid. Acetylsalicylic acid, if I remember correctly. Acetaminophen is in Tylenol, but same thing. If I have a headache and I take some Tylenol, and then my headache goes away, well, on the mind-brain correlation thesis, that must be because the acetaminophen has caused the right sort of change in my brain and central nervous system. So So they're a lot like correlations. They're not accidental or weird like the Nicolas Cage example. And for there to be a change in the mental state, there has to be a specific change in your brain state. So you might find it helpful to recall the notion of supervenience from chapter one. Does anyone remember what we said about supervenience? If so, please tell us. Well, supervenience is kind of like what's being stated in point number two here. Mental states supervene on physical states such that for there to be any change in a mental state, there must be a change in the physical state. So here, supervenience implies that um, mental states are kind of over and above the physical states, and they change if there is a change. The mental states can change if and only if there is a change in their supervenience base. So if you want to sort of refresh yourselves on the notion of supervenience, check out chapter one. But we will come back to this idea toward the end of our lecture today. Okay, so are there any questions about mind-brain correlation thus far? If there are no questions, we're going to look at different kinds of correlations, which Kim outlines on pages 93, 94, and 95. And we're going to try and compare these cases to the case of mind brain causation. And then we're going to look at how various theories of the mental explain mind-brain correlation. So, example A. Whenever the ambient temperature falls below 20 degrees Fahrenheit and stays there for several days, the local lakes and ponds freeze over. Why? The answer, of course, is that the low temperature causes the water in the ponds to freeze. These two events are causally related, and that is why the observed correlation occurs. So, pretty straightforward, right? Grant says, does the mind work only in the brain, or is it throughout the entire nervous system? Like, do I have a mind in my toes? That's a great question. And it's not really one that Kim discusses very much. Or rather, this book does not really. So here's okay. I'm trying to put this in such a way where I'm not like trashing Kim's book. But there's this idea of embodiment and the extended mind hypothesis. Kim does not really focus too heavily on this stuff. But there are people like Clark and Chalmers. So Andy Clark and David Chalmers wrote a very influential paper called "The Extended Mind," um, which argued that cognition is not limited to the bounds of the skull, but is actually kind of like distributed throughout the nervous system, the body of the organism, and even into the environment. Because we use our bodies for thinking, and we use external tools to aid our cognition too. So their argument is that cognition is like extended into the environment. So we're not just brains in vats. We're in, we have minds, but we're also embodied creatures, and we exist in this dynamic physical environment, which we often use parts of our bodies or features of the environment as like cognitive aids. Think of as something as simple as counting on your fingers. Or the example I use is the expert bartender. So, an expert bartender, when she listens to your order, if you're ordering like 5 drinks for all your friends, she doesn't have to keep the entire list of drinks in her head. What she can actually start doing is like pulling out various glasses which are used for various beverages as she's getting the order. So, you're getting, I don't know, a whiskey sour and a Manhattan and a glass of Merlot and scotch and whatever, right? Those all go in different glasses. So if she gets those glasses ready as she's taking the order and then, goes and starts preparing one drink, comes back, what one's next? There's the Merlot glass. Okay, glass of Merlot, right? So it's like she's using the environment as an external memory. Another interesting one is expert Tetris players. So expert Tetris players, when they're playing Tetris, they don't use mental imagery to try and orient the blocks to see how they should go as they're falling. They use the screen itself, and they just rotate things on the screen to get them into position rather than trying to imagine how they're supposed to go. So these are all examples. Clark and Chalmers' example involves a couple of people named Otto and Inga. Now I think it's Otto has Alzheimer's, so he uses like a notebook as an external memory, and by doing this, he's able to remember the same sorts of things that Inga can remember, uh, who doesn't have dementia. Um, so I don't know if you have a mind in your toes, Grant, but there is a sort of collection of philosophers and cognitive scientists, the extended mind people, who say that yeah, in an important sense, the mind does extend out of the head into the rest of the body and in the environment. Maybe we'll be able to talk about that more at another time. Um, okay, so getting back to example A. Why does the water freeze when the temperature drops below 20 degrees Fahrenheit? Of course, I don't know Fahrenheit. Why does the water freeze when it drops below 20 degrees Celsius? Well, this is a causal relation. So um, there's it's not a mere correlation between minus 0 degrees Celsius temperatures and water freezing. It's also a causal relationship. Water freezes, it changes states when the temperature drops below 0 degrees Celsius. So if the temperature outside drops below the freezing point of water, the water freezes, and that's a causal relationship, and that's very straightforward. Again, unlike the Nicolas Cage and drownings example. So that's a pretty straightforward thing, right? Like there is a correlation between A and B, and the correlation is there because A causes B. Very straightforward. Now, example two, quote, you enter a clock shop and find it an astounding scene. Dozens and dozens of all shapes and sizes, clocks of all shapes and sizes are busily ticking away, and they all show exactly the same time, 2 o'clock. A while later, you see all of them showing exactly 2:30, and so on. What explains this marvelous correlation among these clocks? Here, a common cause, the shopkeeper's actions in the morning, explains the correlations that are now observed. To put it another way, one clock showing 3:30 and another clock showing the same time, 3:30, are collateral effects of a common cause, and that common cause is the action of the shopkeeper, who every morning makes sure all the clocks are synchronized with one another. So clocks A and B both show 3:30 p.m. at the same time. That's because there's a common cause, C, which caused A and B. Make sense? Another clock case, same thing. We have a clock shop and we go in and unbeknownst to us, these are very inaccurate clocks. They gain or lose time every 5 minutes or so. But Kim tells us there's a leprechaun who lives in the clock shop and he runs around the shop unseen by the customers and synchronizes all the clocks every minute. Now, this is quite ridiculous. You're saying, "Hey, that's silly. Leprechauns don't exist, and if they did, why should they be responsible for adjusting clocks at a clock shop?" Well, don't worry about that. The important thing is that this is an illustration of continued intervention of a causal agent. So a common cause. So in example B, a single cause in the past is sufficient to explain why all of the clocks are in sync with one another. But here, there's a common cause that continuously intervenes on all of the clocks such that they all stay synchronized throughout the day. So there's no direct cause effect relationship between, well, between the clocks staying, there's nothing going on from clock to clock. But rather there's an outside agent who's causing the clocks to be in sync. It's not like synchronous oscillation where if you put all the clocks on a wall, the vibrations of the clocks passing through the walls will eventually cause the clocks to synchronize. It's not like that. In A, there's a single cause which synchronizes all the clocks, and in B, there's the shopkeeper, the single cause who synchronizes all the clocks, and in C, there's a common cause who continuously intervenes and makes sure the clocks are always synchronized. Okay, so are you seeing the differences here between these different examples of causation? That's the important thing that I think that you're taking note of the differences. No one seems to not be so far, so that's good. Another different example. Why do temperature and pressure co-vary for gases confined in a rigid container? This is the gas law, right? For the physicists and the engineers in the room. Y'all remember the gas law? So the temperature and pressure of a gas are both dependent on the motions of the molecules that compose the gas. Nice. PV equals nRT. Sick. I don't think I actually remembered the formula, but I did learn the gas law back in the day when I was an undergraduate. Um, so the temperature is the average kinetic energy of all of the molecules moving around. You know, molecules move. And when those molecules are moving around very, very fast, we get a high temperature. Very slow, we get cold temperature, right? So think of the ice, right, on the pond. Those water molecules are locked in place in a sort of crystalline form, right? Liquid water, the water can move around. When we boil the water, while it's boiling, the water's moving all over the place, and there's bubbles coming out, right? Um, so that's our temperature. It's the mean kinetic energy of the molecules. The pressure is the momentum that these moving molecules impart to the walls of the container per unit area. So we can talk about a container containing, you know, gas at such and such a pressure, like PSI, like pounds per square inch or whatever we want, right? So a rise in temperature and a rise in pressure here can be viewed as two aspects of one and the same underlying microprocess, basically the motions of these little gas molecules. So if I take some gas and I compress it, the pressure will go up and the temperature will go up. So there will be a cause in there will be a change in pressure and temperature, and the common cause of both is the motions of the molecules. So their average kinetic energy, the average kinetic energy of the molecules, and the pressure that they impart to the walls of the container. So these are two aspects of the same thing, how those molecules are moving. Make sense? So, you know, next time you're blowing up a balloon or using an air pressure, like an air compressor, you can think to yourself, like, okay, the pressure is related. The pressure and temperature are both related, um, owing to how these molecules are moving around. Pretty cool if you think about it. Why does lightning occur when there is an electric discharge between clouds or between clouds and the ground? Well, because lightning just is an electric discharge involving clouds and the ground. There's only one phenomenon here, Kim says. There are not two that are correlated with one another. That is to say, electrical discharge in the atmosphere is not correlated with lightning. Electric discharge in the atmosphere is lightning. So here we've got two things that seem to be correlated, but when we look closer, we see that there's actually no correlation because they're the same thing. We have two different descriptions. We can describe it as a bolt of lightning, or we can describe it as electrical discharge in the atmosphere, but it's same thing, same difference. Well, not same difference. There's no difference. They are the same thing. So, as Kim says here an apparent correlation turns out to be an identity. Here's another one. Kim's got a lot of these, so bear with me. Why do the phases of the moon, half, quarter, full, gibbous, he didn't mention gibbous, why do these phases of the moon co-vary with the tidal actions of the oceans, like spring tides, neap tides, and so on? Well, it's because the relative positions of the Earth, the Moon, and the Sun determine both the phases of the Moon and the combined strength of gravitational forces of attraction exerted on the ocean water by the Moon and the Sun. So, changes in gravitational force are proximate causes of tidal actions, and the relative positions of the three bodies can be thought of their distal cause. So, just to make that a little bit more simple, right? The reason why there are tides is due to the relative positions of all these bodies and their gravitational effects on one another, right? So if you have, um, you know, the sun and a new moon and the earth, you have very strong gravitational forces from because of the earth and the moon and the sun on the water. So we get a big tidal bulge at the side of the earth facing the moon and the side facing away. Same with like a full moon. If the moon's over here and the earth is here and the sun's over there, you're going to get that tidal bulge. And you're going to get other tides during other times of the year, but they'll be greatest when these celestial bodies are in certain positions relative to each other. That's the distal cause, the relative positions. The proximate cause, the close cause, is the gravitational influence that all these bodies are exerting on one another. And the phases of the moon, it turns out, are actually collateral effects of the positions of the three bodies involved. They only serve as an indication of what the positions of the bodies are. They don't actually play a causal role. So what does this to say is, say you have a high tide and it's a full moon. It's not because the moon is full that you have a high tide. Rather, you have a high tide and a full moon because of where the Earth, the moon, and the sun are relative to one another. Make sense? I'm sorry that I know this is a lot that I'm throwing at you. And I'm kind of an astronomy nerd, so you need to stop me if this is not making sense. Does this make sense to you? Yeah, a linking feature like it's like you can know like, oh, it's a full moon. The tide will be high. The same way maybe a full moon indicates the middle of the month if you use a lunar calendar. But it's not the cause of the beginning of the month or of the tide. It's the position of the moon relative to the Earth that is the cause of the tide. The phase of the moon is, if you like, almost an epiphenomenon. It's an effect of the relative positions of these three bodies, but it plays no causal role in anything to do with the motions of these bodies. Like for example, when it comes to the tides. Matthew's good because he's an astrophysicist. Good. Um, but if you're not an astrophysicist or an amateur astronomer, um, now you know. You could say perhaps that a full moon or a new moon indicates that you're going to get the tides coming in, but it's not the cause. Now, how does all of this relate to what we were talking about with the mind-brain correlation thesis? Well, um, there are different kinds of mind-brain correlations. Causal interactionism. This is Descartes' interactionist substance dualism, right? Where um, the soul can causally affect the animal spirits via the pineal gland, and the animal spirits can affect the pineal gland, affecting the soul, like a direct causal relationship, right? Like the drop in temperature causing the water to freeze. This is how the Cartesians think it works. It's a causal interactionism. A causes B, which causes C, etc., etc. Um, a lot of and Kim does go into certain detail on this. A lot of the contemporary rationalists, um, contemporary with Descartes, had a problem with his interactionist substance dualism. I mean, we saw this when we looked at Elizabeth of Bohemia. She said, "Look, you're saying that a non-physical thing it can interact with a physical thing, um, but we need things like touch and extension, and how can something that's non-material, which is not extended and can't touch anything, can't push or pull against anything, how can that work?" Elizabeth said that, and I'm paraphrasing here, that she would rather grant that the mind is material than grant that an immaterial soul can affect or be affected by a material body. So one answer to this was, as I've mentioned before, Spinoza, Baruch Spinoza, who said that, well, there's really only one substance, and that's God or nature. Um, and it has lots of different um, attributes, two of which are thought and extension. And each of us is a finite mode of God or nature, which has each of the attributes. So because we're dealing with one substance and not two, there's no interaction problem for Spinoza. Leibniz does something different with his monads. Monads are like little bits of fundamental substance. And they appear to interact with one another, but it's actually all pre-established harmony. So you can think here of the clock shop keeper who goes in and readjusts all of the clocks every morning, so that they all match up throughout the day. It's a pre-established harmony. It's a weird notion, okay? Like, because we're used to thinking of causation in terms of physical causation, like when you're playing a game of pool. So when you play a game of pool and you strike the cue ball with the cue stick, and the cue ball strikes the eight ball, and the eight ball rolls into the corner pocket, you see all of those as causally interrelated, correct? So, A causes B, causes C, causes D. The cue stick strikes the cue ball, which strikes the eight ball, which rolls across the table and then falls into the corner pocket. Leibniz's pre-established harmony says something like the following. It says that, well, there was no actual causal interaction. It was a pre-established harmony. So at the beginning of the universe, God just set it all up so that you would move in such a way, and the cue stick would move in such a way, and the cue ball would move in such a way, and the eight ball would move in such a way. It's not each action causing a subsequent action. Rather, it's all pre-established harmony. Rather like the synchronization of the clocks in the morning by our shopkeeper. What about quantum mechanics? Well, Leibniz had no idea about quantum mechanics, but are you talking about like quantum indeterminism? Okay. Yeah, so Leibniz had no idea about that. Leibniz is working, Leibniz is a contemporary of Newton, so he is still looking at the universe like a clockwork universe, right? In fact, I think I mentioned Leibniz is the co-discoverer of calculus along with Newton. Um, and I believe the system of notation that we use for calculus is actually Leibniz's, rather than Newton's, which is interesting. But yeah, he's old, and he's working at a time where we were still like working with materialism rather than like physicalism. So we didn't know about quantum stuff. Um, and Leibniz thinks like, well, how do we explain this clockwork universe? Well, it's because all of these monads, which make everything up, are working with this sort of pre-established harmony. It's like when you watch an animated film, right? No actual physical interactions in the film are happening. So if Wile E. Coyote tries to drop a big rock on the Roadrunner, and then the rock actually falls on him because of some problem with his apparatus, that's not because there's actual physical causation. It's because that's the way the cells were drawn and then animated, right? It's kind of like that for Leibniz. Um, Double aspect theory. As I just said, mind and body, that is extension. So cognition and extension are modes of the same substance, which is God or nature. It's the same thing to Spinoza. Spinoza was a pantheist. So there aren't two substances, only one, God or nature, and it has it has modes, two of which are thought and extension, and we're all finite modes. We're all finite modes which have these, sorry, attributes of thought and extension, not modes. We're the modes. Um, this is a bit like if you want to think about the gas law again. Um, so you have an increase in temperature and an increase in pressure. Those are two aspects of the same underlying process. So thought and extension for Spinoza are like two aspects of the same substance. Dual aspect theory is associated with Spinoza, but also William James, interestingly. With James, it's often called like a neutral monism, which is almost like a kind of property dualism. Here you've got one substance, the physical substance, but it's got two sorts of aspects or attributes or sets of properties, physical and mental. So that's dual aspect or double aspect theory. Then you have epiphenomenalism. We're going to read more about this as the course goes on, but T.H. Huxley, Darwin's bulldog, is known for epiphenomenalism. His example was the steam whistle on a locomotive. Uh, the steam generated by the locomotive powers the train, and if we want, we can use some of it, divert it, and blow a whistle. But the blowing of the whistle has no effect on the workings of the locomotive. It's an epiphenomenon. But as far as the examples we just went over, think of the lunar phases, right? The lunar phases are not the causes of the tides. They can be used as indicators of tides, but they're not the cause of the tide. Rather, they're an epiphenomenon. It's the relative positions of the Earth, Moon, and the Sun, which are the cause of the tides. Then there's emergentism. So correlations between the mental and the physical here are like brute facts. They are just the way. That's just the way it is, right? Um, Consciousness emerges from the complexity of certain physical processes. So maybe the brain is very complicated, so complicated that by virtue of its complexity, mental properties emerge, and that's just the way it works. And we're not going to explain it beyond that, right? And then there's identity theory, which we're concerned with today. The brain just is the mind. The mind is the brain, just like lightning is atmospheric electrical discharge. It's not correlated. Lightning is not correlated with atmospheric electric discharge. It is atmospheric electric discharge. And that's what identity theory says about the mind. The mind is the brain. Kinds of mental states, and this is type physicalism, types or kinds of mental states are just types or kinds of physical states, namely brain states. And one argument for this comes from J.J.C. Smart, an Australian philosopher who wrote the following. He said, "Why do I wish to identify sensations with brain processes?" That's the title of his paper, Sensations and Brain Processes. "Mainly because of Occam's razor. There does seem to be, as far as science is concerned, nothing in the world but increasingly complex arrangements of physical constituents. All except for one place, in consciousness. That is, for a full description of what is going on in a man, you would have to mention not only the physical processes in his tissues, glands, nervous system, and so forth, but also his states of consciousness, his visual, auditory, and tactual sensations, his aches and pains. That these should be correlated with brain processes does not help. For to say that they are correlated is to say that they are something over and above these brain processes. So sensations, states of consciousness, do seem to be the one sort of thing left outside of the physicalist picture. And for various reasons, I just cannot believe this can be so. That everything be explicable in terms of physics, except the occurrence of sensations, seems to me, frankly, unbelievable. So he's appealing to Occam's razor. It's it's simpler to identify sensations and other mental states with brain states because it doesn't make sense, at least to Smart, that the mental is something over and above the physical. Why should we need anything over and above the physical to explain sensations and brain processes, or to explain sensations, rather? Well, I agree with Smart on this one. Yeah, I mean, that would be like, I'm a physicalist, so I believe that whatever our mental states are, ultimately, I think they arise out of the physical. But here, Smart seems to say that, well look, we try to explain sensations and consciousness. We can't really do it with the physical. We seem to require something more than the physical. But that's too complicated. That violates Occam's razor. So let's identify mental states with brain states. Let's talk about Occam's razor. There are two formulations that we often see of Occam's razor. One is the ontological formulation. It says entities must not be multiplied beyond necessity. What this means is that we don't want to posit entities or beings that don't do any explanatory work. The second is what we call the principle of parsimony. What can be done with fewer assumptions should be done with few assumptions, not more. So you want to use the fewest number of unwarranted assumptions as possible. So do not posit entities that don't do any explanatory work, the ontological formulation of Occam's razor. Think of the synchronized clocks in the shop. What's the simplest explanation in terms of how many entities we need to appeal to? We can explain the synchronization of all the clocks either with the shopkeeper synchronizing them in the morning, or two, with the shopkeeper synchronizing them in the morning and a little leprechaun who runs around and resynchronizes all the clocks every 5 minutes. I mean, come on. What's the simpler explanation? Well, the simplest explanation is the one that does not involve the leprechaun. We don't need the leprechaun to explain why all the clocks are synchronized. What are some other examples of Occam's razor where we applied in say the history of science or philosophy where we've applied Occam's razor to eliminate beings that don't do any explanatory work? There's a lot of examples. Okay, so my astrophysicist friends, did you guys ever learn about uh, the Ptolemaic model of the solar system? You know, like when you're learning about the heliocentric model and Copernicus and Kepler and all those cats. Do you ever learn about Ptolemy's model? Okay, so Ptolemy's model was weird, right? Because he had to explain retrograde motion. And he did it with these weird crystal spheres. So the planets are situated on these crystal spheres, which are also moving. And that explains retrograde motion. So throughout the year, you can go outside and watch the planets as they move through the sky over the year, and you'll see that for a period of time every year they appear to move backward for a few months and then go forward again. Ptolemy tried to explain that with these weird crystal spheres. So it's like wheels within wheels, planets orbiting the Earth, not the sun, and planets going around these crystal spheres as they're orbiting the Earth, right? That's how Ptolemy did it. Along came Copernicus, who said, what if we put the sun in the middle? Um, and then maybe we can explain retrograde motion owing to the relative positions of the Earth and the other planets that are all going around the sun at the same time. Now, here's the interesting thing. Copernicus's model did not work any better than Ptolemy's. They both worked the same when it came to predicting where the planets would be at different times of the year. Copernicus's model did not do any better than Ptolemy's. It was the right model, mostly, but why did scientists eventually abandon Ptolemy and go with Copernicus? Because Copernicus's model was simpler. It didn't need crystal spheres to explain retrograde motion. Um, and then we gradually honed it when Johannes Kepler, Tycho Brahe, they came along. They figured out the planet laws of planetary motion. We figured the planets go in ellipses, not circles. Um, and so now the heliocentric model works way better than the Ptolemaic model, and we also know it's true because we've like gone to space and seen it, right? Um, yeah, exactly. Well, yeah, like Ptolemy needed all that extra stuff because he was committed to the idea that the Earth was the center of the cosmos. But once we had our Copernican revolution and we put the sun at the center, our model of the solar system became much simpler. And that's an application of the ontological principle. Do not multiply entities beyond necessity. Uh, and use the fewest number of unwarranted assumptions as possible. We can apply this to Ptolemy's model too. He assumed that there must be these crystal spheres because he was committed to the idea that the Earth was in the center, not the sun. Um, that was an unwarranted assumption. Um, the idea that there were crystal spheres was an unwarranted assumption. So these are both like saying quite similar things. It's just slightly different ways to put them. Grant says Einstein made an assumption that the speed of light is constant for all observers. Then he built this the entirety of special relativity harder, but still only one assumption. Yeah, yeah, that's a good example too. Um, so, um, uh, and you know, Einstein was trying to, I mean, he wanted to know about what it would be like to travel at the speed of light and how light propagated through space. Another example, you know, of an unnecessary entity or an unwarranted assumption would be the luminiferous ether, which prior to Einstein is how scientists thought that light propagated through a vacuum. They thought it actually propagated through a medium called the ether. Um, Einstein dispensed with that. Um, so again, that's another example. You can find a lot of examples when you get these sort of like paradigm shifting discoveries, like the heliocentric model of the solar system or special and general relativity. You can see like where someone has come along and said maybe one of our assumptions is wrong and we need to get rid of it and rethink it, and that's Occam's razor at work, right? So to bring it back to smart, right? The idea is that we don't need the mental, we don't need the physical and the mental. We just need the physical. That would be simpler. It would be more parsimonious and it would be ontologically simpler. So how do we do that? Well, we just identify the mental with the physical. Like how when we see lightning, it's not Zeus throwing thunderbolts, it's not Thor beating his hammer, it's static electricity discharge in the atmosphere. And even the static electricity discharge is not correlated with lightning. It just is lightning. That is just what lightning is, right? So that's what we want to do. We want to simplify our ontology. So we identify the mind with the brain. Um, and that also seems logically or linguistically simpler too, you know, because we can still talk about the mental. We still have mentalistic language, you know. I believe this, I desire that, I'm thinking about such and such. But we realize that those mental states, talk about those mental states is really talk about brain states. It's like a shorthand for brain states. Um, And finally, quote, and this is what Smart seems to have in mind. Suppose we stop short of identifying pain with C fiber stimulation and stick with the correlation. Pain occurs if and only if C fiber stimulation occurs. Well, now we have to explain a correlation, and it would just be simpler to explain it away, as it were, with an identity. So, you know, in science, we explain laws and correlations by deriving them from more fundamental laws and correlations. Um, the question for us is, are there more fundamental correlations from which we can derive something like pain occurs if and only if C fiber stimulation occurs? Smart seems to be thinking, no, we ought to just I we ought to just establish an identity rather than causal relation. Make sense? Well, here's how Kim explains it, okay? Um, on page 101, compare this bloated picture with what we get if we move from psychoneural correlations to psychoneural identities, from pain occurs if and only if C fiber stimulation occurs to pain is C fiber stimulation. Pain and C fiber stimulation are one and not two, and we are not faced by two distinct phenomena whose correlation needs to be explained. In this way, psychoneural identities permit us to transcend and renounce these would be correlation laws, what Herbert Feigl aptly called nomological danglers. So I get a real kick out of that term. Philosophers love to make up funny sounding words. This is one of them. What's a nomological dangler? Okay, so nomological here is relating to like law-like relations or orderly relations. Comes from the Greek nomos, like law or order. It's in our word astronomy, right? Astronomy, the order of the stars, the laws of the stars. Okay, so or think of the word like anomaly, something out of the ordinary. It's like unorderly, unlaw-like. A nomos. It has the a privative and nomos. So an anomaly is something out of the ordinary in the sense that it seems to break the known laws of reality, right? So a nomological dangler is a law-like correlation that we need to explain, but that really we don't need to explain. So, whoops. So the nomological dangler appears here. Pain occurs if and only if C fiber stimulation occurs. Well, now we have to explain this correlation. But what if there's no correlation to be explained? What if pain just is C fiber stimulation? So this is a nomological dangler. We don't need to explain it. It's just like a dangling thing we can get rid of with an identity relation instead of an explanation for a correlation. Matt says even after several other astronomers already suggested the heliocentric model, Bro went back to saying the Earth is the center. He was kind of a bum. Oh, that's Ptolemy. Yeah, well, there was this ancient Greek guy, Aristarchus, who suggested that the sun was at the center of the solar system. And we don't know for sure, but it's possible that Copernicus was aware of this work. He might have been aware of this work either directly or indirectly, because this was also the time when a lot of this knowledge was kind of flowing back into Europe from the Middle East. So, like in the Middle East, there were a lot of astronomers in the Arabic world, in Persia. Both there had been astronomy going on in India for a long, long time that was also kind of making its way to the Middle East. And so while Europe was in the Dark Ages, in the Middle East they were doing crazy astronomy, and a lot of that eventually made it back to Europe. So it's possible that Copernicus was aware of some of this, but I don't know if we know for certain. Um, I know that's kind of not we're not in a history of astronomy class, but anyway. I had a thought about subjective versus objective, which is sort of off topic. Grant says, I cringed and maybe felt a bit of pain when I've seen someone kicked in their privates. Yeah, man. Me too. Why is their subjective experience felt by me? I know I'm not feeling their pain, but why is their pain still described as purely subjective? Well, here I think you're describing what we could call sympathetic pain. Um, and really it's owing to your mirror neurons. Um, so if you see somebody getting kicked in the privates, your brain represents that using the same neurons that it would use to represent your getting kicked in the privates, which is why you get this sort of cringy, visceral reaction to it. So it's still subjective though, because your experience is your own, and the poor individual who's been kicked, his experience is his own. Uh, so kind of. That's the rubber hand illusion. That's a little bit different. Um, it's kind of it's in the same sort of phenomenon, but it's not exactly realized the same way on a neurological basis. But it's similar idea. But yeah, that's called the rubber hand illusion. Yeah, look into that. That's interesting research right there, the rubber hand illusion. Um, Okay, so we want to get rid of our nomological danglers. We want to get rid of correlations that might not be correlations, right? Because we might go on ad infinitum trying to explain this correlation. Maybe it's just simpler to say pain just is C fiber stimulation. Um, Now, wait a minute. Here, the reader, Kim says, is invited to reflect on the following simple question. Doesn't the psychoneural identity theory merely replace psychoneural correlations with an equal number of psychoneural identities, one for one? Maybe things aren't that much simpler. The argument from simplicity, it would seem, appeals to the simplicity of identity statements over correlations, but things aren't really that simple because it turns out we would need an equal number of identity statements as we would correlations that need to be explained. So the argument from simplicity, Kim says, maybe doesn't actually simplify things as much as we would like, or as much as the identity theorists would like. Cole says, I know even thinking about the word leg triggers some of the same neural activity that goes on when you actually move the leg. Yeah, likewise imagining. And this has been a huge topic of research for sports psychologists, for example. Like sports psychologists will say, it's important to practice your sport, in the gym or wherever, but you can also visualize it, and that actually helps too. And pilots do this as well. Pilots will do like a whole takeoff and landing in their imagination before doing like some kind of evaluation. And it's been shown that it helps. So visualization, imagination can all help. Okay, now, so listen, we're the 14th slide. We're just about at the halfway point, and I have 3:45 on my microwave. So I think we should take a 15-minute brain break. Sound good? I think we should still be able to finish on time, even though I've been going on a lot of digressions today. Timothy, go ahead.
I have a, well, it's not like directly related to the class, I guess, but I have a quick example of Occam's razor that I can bring up.
Yeah, yeah.
So let me make sure I got this correct. So uh, in my was this reflection one, I may have made a typo in my last sentence that contradicts my whole conclusion because I
Okay.
left out the word not.
Mm.
So I'm wondering if that's okay. Like it's
Um,
it's pretty clear that what I meant, like what I meant to say, but
yeah. Well, I guess I won't know until I've read it.
right.
So
Maybe you won't notice it.
I might not. But thank you for telling me. I'll be on the lookout, and
Yeah.
if I catch it, I'll say I think you might have meant this.
Yep.
So don't worry too much about that.
Okay,
Um,
great.
yeah.
Yeah, it's okay if it costs me because it's a
Well,
typo, but yeah,
it's not a severe error from the sounds of it, but
like it
like
just looks
don't.
funny.
Yeah, yeah.
Yeah.
I wouldn't stress about it.
All right, thank you
And
very much.
Cole says so Cole mixed up property dualism and type physicalism. Is that what you're saying? Look, little things like this happen. This is why we do these assignments. If you lose a couple marks because of a little mistake like this, chances are next proposal or next assignment or on your
Yeah,
essay
I'll
proposal in
be on the
final,
lookout for that.
yeah,
Yeah.
yeah, yeah, you're going to be fine. So like, you're not going to come in here and ace everything. You're building up your skills as part of doing this work. So, just because you make a couple mistakes doesn't
Yeah.
mean you've done a bad job.
I guess I
Uh,
can quickly just tell you the mistake. Like, I was writing about consciousness,
hmm
and my what I wanted to write was since the character appears to like show signs of consciousness, reasoning, and self-awareness, but since I left out that word, it says since he possesses.
Yeah. Well, again, like, don't worry about
Yeah.
it. I give quite detailed feedback on even things like phraseology in these assignments. So, um, and Jack and I will try and be as constructive as possible in terms of the remarks that we make. So don't sweat it.
Yeah.
Okay, so now I have 3:48 on the clock. So we'll come back in 15 minutes. We'll come back at 3 minutes after 4. Okay?
Sounds good.
I'll see you all then. All right. All right. So we're back, and I'll share my screen, and we can resume our discussion of the psychoneural identity theory. So, um, yes, I know I'm sharing my. Thank you, Zoom. Okay. So we were just talking about eliminating, we want to eliminate these nomological danglers, right? The idea is that if we've got all these mind-brain correlations, so pain occurs if and only if C fiber stimulation occurs. Um, beliefs of such and such a type, like your belief that Ottawa is the capital of Canada occurs if certain neurons, if and only if certain neurons are wired and activated a certain way, etc. We have all of these um, correlations that we would have to explain. Why not make it simpler and just say, um, pain is C fiber stimulation? Okay, is that really simpler? Maybe, but maybe now instead of a number of, a whole big number of correlations that we have to explain, we've just swapped them all with identity statements. And we have like a potentially indefinite number of identity statements now. Is that really simpler? Um, I mean, some philosophers, namely the identity theorists, the type identity theorists, would claim that these psychoneural identities are helpful um, because they can explain certain facts or certain phenomena that would remain unexplained, and this is why we should accept mind brain identity. I mean, just think back to what Smart said. It's simpler to explain the mental in terms of the physical and not as something that's over and above the physical. Some also, Smart made an appeal to Occam's razor, but some make an appeal to the principle of inference to the best explanation, and that's what we're going to be looking at going forward. Well, we need a definition of pain, but what Kim is saying that the identity approach might not be simpler because while it eliminates correlations, we still have like an indefinite number of identity statements. Like think of every possible mental state there could possibly be. We haven't really simplified anything in the sense that now just instead of a list of correlations, we have a list of identities. So the principle of the inference to the best explanation, Kim gives it to us as follows. If hypothesis H gives the best explanation of phenomena in a given domain when compared with other rival hypotheses like H1, H2, H3, etc., we may accept H as true, or at least we should prefer H over H1, H2, H3, etc. So the idea here is that our identity statements like pain just is identical with C fiber stimulation. These identity statements offer a better explanation than rival theories, rival hypotheses, like mind-body dualism, for example. And that's, I think, probably what you have in mind, Matthew. It is different. It is maybe still preferred because we need some explanation, and maybe the best explanation is just that we define pain as C fiber stimulation. That's better than, I don't know, Cartesian dualism, right? So that's where the principle of inference to the best explanation kicks in. So explanatory argument one, whoops. Well, where have I landed here? Oh my goodness. So maybe we want to come up with some explanatory argument like, pain just is C fiber stimulation. So these take the explanandum, that is what is to be explained, to be psychoneural correlations, claiming that psychoneural identities give the best explanation of psychoneural correlations. So how do we explain these correlations? We explain them away. We say that they're not really correlations. The better explanation is just that they are identical. So that's what explanatory argument one states, and what it wants to explain are the correlations. It does so by explaining them away. So specific identities like pain is C fiber stimulation or consciousness is pyramidal cell activity explain the corresponding correlations. For example, pain occurs if and only if C fiber stimulation occurs, or a person is conscious if and only if there's pyramidal cell activity in the brain. We explain these using an identity. You can use the analogies kind of like what kind of similar analogies to what Kim does, which is the Superman example, right? Why does Clark Kent turn up wherever Superman turns up, or why does why does Superman perhaps more accurately turn up wherever Clark Kent is, right? Clark Kent's around. Lois Lane is like, oh my God, that child is falling from the building. Oh, Clark. Oh, Clark's gone. Where'd he go? I don't know, but there's Superman saving the poor child. And then after Superman saves the day, Clark shows up again. That's weird. How do we explain that? Well, simple. Clark Kent just is Superman, right? Same with Bruce Wayne. Bruce Wayne's around. He seems to be around whenever Batman turns up. Kind of like in The Dark Knight, right? Where Bruce Wayne's at a party and the Joker shows up, and then Bruce Wayne disappears, and all of a sudden Batman shows up. Um, well, because Bruce Wayne is Batman, but you don't know that because, he's Batman, so you can't tell. Or Walter White, he cooks the same crystal meth as Heisenberg does. Why? Well, he is Heisenberg, right? So, simple. Oh, what's with this correlation between Clark Kent and Superman? Well, Clark Kent just is Superman, and vice versa. Same thing here. How do we explain the correlation pain occurs if and only if C fiber stimulation occurs? The explanatory argument says that um, identifying pain as C fiber stimulation is the better explanation rather than, pain occurs when there's tissue damage, which excites the animal spirits, which affects the pineal gland in such a way, which then affects the soul in such a way, right? That's the idea. So when it comes to pain, pain just is C fiber stimulation on explanatory argument one. And that explains the correlation because we've kind of explained it away, right? So pain equals C fiber stimulation. Therefore, pain occurs if and only if C fiber stimulation occurs. And we can expand this to other kinds of mental states too. So for every mental property M, there is a physical property P such that M equals P. So for every mental property or event or process or whatever, there's a physical property, event, process, and we can identify those mental events with those physical events. Those physical phenomena can get identified with those mental phenomena. So for every mental property M, there is a physical property P such that M occurs if and only if P occurs. Make sense? So when it comes to pain, let's limit ourselves to pain. If A is a good explanation, that is the best explanation, then yay. So if pain just is C fiber stimulation and pain occurs if and only if there is C fiber stimulation, yay, that's great. But what about A? If A is not a good explanation, then B cannot be a good explanation. If this is not a good explanation, this is not a good explanation. And that means we're not appealing to the best explanation. And that's a problem if we're trying to make an argument to the best explanation, which we are on explanatory argument one. Now, A might not even be an explanation. This is what Kim says. If pain is indeed identical with C fiber stimulation, in what sense do they correlate with each other? For there is here only one thing, whether you call it pain or C fiber stimulation. And as Smart says in the paragraph quoted earlier, you cannot correlate something with itself. For Smart, the very point of moving to the identity pain equals C fiber stimulation is to transcend and cancel the correlation pain occurs if and only if C fiber stimulation occurs. This is the nomological dangler to be eliminated. And further, by opting for the identity, Kim writes, we show that these questions have no answers, since the presupposition of the question, namely that pain correlates with C fiber stimulation, is false. The question, why is it the case that P, presupposes that P is true. When P is false, the question has no correct answer and it cancels itself out as an explanandum. So why is pain correlated with C fiber stimulation? Well, because it's identical with it. Well, okay, Kim says, but that's not really an explanation. And you've canceled out by identifying pain as C fiber stimulation, you've actually canceled out your explananda, the things you want to explain. We might also be getting hung up on this notion of correlation, right? There might not be a correlation. Maybe we could just say, okay, maybe there's no correlation, but what we mean when we say that is that correlation means identity in this context. But then we have questions like why, for example, do we experience pain when our C fibers are stimulated? Why not something else, like itch? We'll notice that identity theory doesn't really dispense with these questions. It kind of takes them as brute facts, like, okay, pain just is C fiber stimulation. And I don't know, maybe itches are a result of eye fiber stimulation. But why isn't it the other way around? Why should it be the way that it is and not some other way, right? So it doesn't dispense with these questions. And identity statements are trivial ultimately. They're pain is C fiber stimulation. Okay. That doesn't really explain by using the identity. I haven't really explained anything. Question. So Kim is saying that pain doesn't exist, only C fiber stimulations do. No, 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 he's not saying that. Pain does exist. What Kim is doing is um, analyzing an explanatory argument for identity theory. What Kim is saying doesn't exist. Well, he's saying that what the identity theorists are saying doesn't exist is actually this correlation between pain and C fiber stimulation. If they're right, there is no correlation. Pain just is C fiber stimulation. But as I was just saying, that kind of brings certain issues of its own. And this argument, explanatory argument one, does invoke the principle of inference to the best explanation. But we've got to remember that this is a scientific rule. It's a rule we apply in inductive reasoning. But in the sciences, it often turns out that explanations of correlations aren't always this straightforward. After all, one way that we explain correlations, as I said earlier in the sciences, is to try and deduce it from more fundamental laws, more fundamental correlations. Let's try and think of some examples. Can you think of any? Well, why does the mercury rise in a thermometer? It's correlated with the temperature. But we explain that the action of the mercury in the thermometer um, by appealing to the properties of the mercury in the thermometer, for example, and temperature as the mean kinetic energy of the molecules in the air in which the thermometer sits, and how that energy is transferred to the mercury in the thermometer, right? So one thing we can do is try to explain a correlation by deducing it from something more fundamental. It's kind of like how, you know, we can explain everything that goes on in chemistry by appealing to the laws of physics. We can explain everything in biology by appealing to chemistry, right? So these, the workings of biological systems are reducible to chemicals and chemistry, and all of that is reducible to physics. So this is the notion of reduction. So we try to explain higher level correlations by appealing to lower level correlations and lower level laws. Another way of explaining a correlation is to show that the two correlated phenomena are collateral effects of a common cause, right? Um, we saw an example of this earlier with the temperature of the gas and the pressure of the container. It could be. It could be. I don't know. I think a lot of scientists are just interested in the mind because, after all, the mind is what we use ultimately to do science. And so it'd be pretty great to figure out how minds work. Like, what are minds? What do they do? What are mental states? Are they real? Are they causally efficacious? It would be good to know because the mind is what we use to do science ultimately, right? So, um, I think that's why a lot of scientists like philosophy, at least this kind of philosophy. Some scientists don't like philosophy at all, but they're missing out. So, sucks to be them. Okay, so these are ways we can explain correlations in the sciences. There's a question of whether we can do the same here with mind-brain identity. Plus, when scientists are looking for the best explanation and they find a good one, they don't stop, right? The scientists in this class know this. When you find an explanation of something that seems to work, you don't just stop. You try and derive new predictions, and then you test those predictions experimentally, right? Kim says the principle of inference to the best explanation gains credibility from its use in scientific hypothesis testing. Using it to support what is an essentially philosophical claim with no predictive implications of its own, and hence no possibility of further tests, seems at best a misapplication of the principle. It can mislead us into thinking that the choice of a position on the mind-body problem is like a quotidian testing of rival scientific hypotheses. I think what Kim is trying to say here is that what we're doing, okay, it's all well and good if you want to use the principle of, the explanation by appeal to or the principle of appealing to the best explanation. That's all well and good. And that really works in the sciences. But philosophy is often doing something very different from what scientists are doing, especially nowadays. Remember what I said at the beginning of the class, right? Philosophy asks fundamental questions. Um, I really like the way that Daniel Dennett put it. He said, philosophy is what you do when you don't know what questions to ask yet. Once you know the questions to ask, you're doing science. But when you're working out how to think about those questions, which questions to ask, that's philosophy. And Kim is saying it's unclear whether the principle of the best explanation really applies here for what the identity theorists are trying to do. So philosophers are doing something like pre-theoretical, pre-conceptual, and maybe applying the principle of the argument to the best explanation is something theoretical and scientific rather than conceptual or pre-theoretical. We can't do an experiment. Here's a real simple way of boiling it all down. There's no experiment we can do that will tell us whether we ought to believe Cartesian dualism or identity theory or functionalism. That's just not what we're doing here, right? So the principle of argument to the best explanation doesn't apply. This is not to say that we can't use this idea. It's called abductive reasoning. It's a type of induction. When we try and explain things, we try and explain by appealing to the best explanation. It's not that it can never apply in philosophy, but Kim doesn't seem to think it applies here. Whether or not you agree with him, that's up to you. In fact, something like this would make a great topic for an essay or a future reflection assignment. So, keep that in mind. So that's it for explanatory argument 1. Now let's talk about explanatory argument 2. What explanatory argument 2 says is that mind-body identities can enable us to explain certain facts about mentality that we otherwise could not explain, right? A fact like it could explain, for example, why pain causes us a feeling of distress. So, for example, let's stipulate that pain is identical with C fiber stimulation. And let's say that distress is neural state N. So pain is C fiber stimulation, and we want to explain how it causes distress, or state N. So we could formulate a neurophysiological explanation for why pain causes distress. So let's look at it. This is our neurophysiological law. C fiber stimulation causes neural state N. And we know that pain is identical with C fiber stimulation. That's identity statement one. So this is our law, and these are our identity statements that kind of tell us what this means. So C fiber stimulation causes neural state N because pain is C fiber stimulation and distress is neural state N. Therefore, pain causes distress. So this is like a law-like explanation for why pain causes distress right here. See how it works? Any questions so far? Okay, well, what if we, instead of using identities, we use correlations? We might get something like neurophysiological law 1. C fiber stimulation causes neural state N. And here are the correlates. Pain occurs if and only if C fiber stimulation occurs, and distress occurs if and only if neural state N occurs. Therefore, pain correlates with a phenomenon that causes a phenomenon with which distress correlates. Any questions? I know I'm throwing a lot at you here. I say that a lot. I'm throwing a lot at you. I really am. Or should I say, Kim is throwing a lot at us because it's a pretty substantive chapter that we're in here. Any questions? Well, the correlations don't seem to do much explaining. Identity theorists would say that identities do the explanatory work. So what we should do is reject this, neurophysiological laws 1, and accept something like this, neurophysiological laws 0. That's the one we should accept. Because this is not explaining anything. The identity theorists would say, like, okay, C fiber stimulation causes neural state N. Pain occurs if and only if C fiber stimulation occurs. That's a nomological dangler if you're an identity theorist. And so is C2. Distress occurs if and only if neural state N occurs. Also a nomological dangler. So here all we've got is like pain correlating with a phenomenon which causes a phenomenon with which distress is correlated. And there's all these nomological danglers in there. So they would say accept 0 but reject 1. The point here, and this is the point Kim wants us to accept, is that for an identity theorist, quote, these identities enable desirable psychological explanations while disabling the improper demands for explanation of psychoneural correlations. But Kim rejects this. Kim says this is wrong. He argues, quote, the trouble is that in both arguments, the identities in question do not seem to do any explanatory work, and hence are not qualified to benefit from the principle of inference to the best explanation. Indeed, we can say like, oh, this one here is full of nomological danglers, but if we go back here, this, identity statements 1 and 2 don't really do any explanatory work either. So neither of these are qualified to benefit from the principle of inference to the best explanation, as Kim says. Indeed, these identity statements just re-describe facts. They don't explain anything. Well, pain is C fiber stimulation. The equals grant where you've got C fiber stimulation equals M, there shouldn't be an equal sign there. Rather, these would occupy their own lines. Like if you were doing this, if you're writing this out logically, like Kim does here, like I've quoted him on slide 20, these would each get their own line. But pain, so C fiber stimulation causes neural state N. And C fiber stimulation is pain and N is distress. So And what Kim is saying here is that this is all just, it's not an explanation, it's a re-description of what we already know. We haven't explained anything. We've just stated what we already know with different identifying labels, if you like. It's like saying, okay, there's this old thing people used to try and explain why opium makes you sleepy. I don't know which author originally wrote this, but upon being asked for an explanation of why opium made one sleepy, this thinker replied by saying that, well, opium has a dormitive virtue, which is a fancy way of saying it has the power to make you sleepy. So this is like that. Like, why does opium make you sleepy? It has a dormitive virtue. Is like saying it's just another way of saying it makes you sleepy. It makes you sleepy because it makes you sleepy. Okay, you haven't explained anything. You've just re-described the fact that opium makes you sleepy. See what I mean? Same thing is going on here, Kim thinks. Or like, why does my coffee cup contains liquid because my coffee cup has volume? Sure. I mean, volume is something separate from this particular cup, I guess, but you could also argue that I've just re-described the fact that my coffee cup can contain liquid. So we're just re-describing facts. That's not going to work for Kim. So are we all clear on why explanatory arguments one and two don't really work, according to Kim? Again, some of you might really dig identity theory and you might disagree with Kim. And that's fine. I always tell my students, right? I'm not here to tell you what to think. I'm here to teach you how to think. And some of you might find identity theory perfectly fine as a theory of the mind. And maybe you can defend it in your essays or in your next reflection assignment. That's fine. But these are the problems Kim sees with it. Now, another argument, an argument from mental causation. What's mental causation? Well, we're going to have a whole chapter where we look at this. So we're not going to get too far into the weeds here. But mental causation is the idea that mental processes can affect physical processes and be affected by physical processes. Kim's example, paper cut. You get a paper cut, or like me, you cut yourself making French fries. We got one of those like potato slicer things where you put a potato in it and you put a thing on top and smush it down, and the potato becomes French fries. And I cut myself on that thing. I trace the causal chain backwards. How does the physical affect the mental? Well, I've suffered some tissue damage in my. Actually, it's here on my thumb. I suffered some tissue damage in my thumb. And so nerve signals start traveling up to my brain where I guess my C fibers and my A delta fibers fire and I experience pain. So I go from the physical to the mental and then presumably back to the physical because I withdraw my hand from the painful stimulus and I go, ouch. So the physical, we go up the physical causal chain to the mental and then back through to the physical. So Kim says on 111, the chances are that the causal chain culminating in your hand's jerky movement, withdrawing it from the painful stimulus, when traced backward, will completely bypass your pain. There will be more and more neurophysical events as you keep going back, but no mental experiences. Yeah, there's a good point there. Um, in my little description of this causal chain, I included the mental, but um, you don't have to. You could give an entire description of the causal chain from cutting your finger to the behavioral stuff, going ouch and withdrawing your hand, um, without without including anything mental in there. So, where's the role for pain? Maybe pain is an epiphenomenon. Here's a more systematic version of the argument, which this is where things start to get a little spooky. So, first premise says that mental phenomena have effects in the physical world. I experience pain and I withdraw my hand from the painful stimulus, say, or I cry ouch and I hold my thumb because it hurts. Premise two states something that we call the causal closure of the physical domain. So the physical world is causally closed. What that means that if any physical event is caused, it has a sufficient physical cause and a wholly physical causal explanation. Therefore, mental phenomena are physical phenomena. This doesn't say that every physical event has a necessary physical cause. That would be determinism. And we're not going that far here. What the principle of causal closure of the physical domain says is that if there is any physical effect, you never need to go outside of the physical to explain that effect. The cause will always there will always be a sufficient physical cause. So if I've cut my finger, there's no need to posit anything non-physical like an unextended Cartesian thinking substance. There's no need to do that. The causal chain can be physical, and we're led to the conclusion that mental phenomena must be physical phenomena. So why not just identify them with the mental phenomena with the physical brain states, right? That's the idea. Kim elaborates on this. This is the conclusion which stands. Mental events that have effects in the physical domain are really just physical events. Kind of paraphrasing there. To quote directly, the pain that causes your hand to pull back in a jerky motion and makes you cry ouch is a physical event. But which physical event? What better candidate is there than the brain state that is the neural correlate of pain, namely C fiber stimulation? C fiber stimulation is a necessary and sufficient condition for the occurrence of pain, and it occurs at exactly the same time as the pain. Yeah. Well, think about it. Like the causal closure of the physical. I mean, um, it it's a really powerful principle in naturalism. So naturalism is a metaphysical theory, which is really based on the huge success of the physical sciences. Naturalism says that the only things that exist are natural things. Well, that's metaphysical naturalism. That's the metaphysical theory. Metaphysical naturalism says that the only things that exist are natural things. In other words, physical things, the kind which ultimately, like at the level of ultimate reality, the most fundamental level of reality, what exists are the things that would be studied by physics, and everything else, chemistry, biology, maybe the cognitive sciences, are all kind of reducible to that stuff. So that's metaphysical naturalism. The weaker version is methodological naturalism, which is how most scientists actually operate. Most scientists might say, oh, there might be a soul, there might be a God. These are supernatural things, but it's not scientists' job to study those things. Science studies the natural world, not the supernatural. But metaphysical naturalism says, no, there's just the natural. There's just physical stuff, atoms, force fields, etc., right? And a part of naturalism is the causal closure of the physical. So it's causally closed in that whatever's doing the causal work, whatever effects we observe, we can always find a sufficient physical explanation, a sufficient physical cause. We never need to go outside of the physical. So that's really great for doing science. It's not so great if you are perhaps like a religious person and you believe in miracles or something. Um, or if you're like a Cartesian dualist and you believe in a non-physical, non-extended thinking substance. Um, the causal closure of the physical kind of disallows that. Um, but anyway, ultimately, where we get is to this point where if the mental events have physical effects, then they must also be physical. The mental must be physical. And this leaves us with a choice. We can go with identity theory. Mental events are just physical events. Mental states are just physical states, namely in the brain. Or we can be epiphenomenalists. And this is the spooky part because epiphenomenalism about the mental says that the mental is all effect, no cause. So maybe the mental is caused by the physical, but is causally inert. Yeah, no free will. That's an implication for some. For some, not for everyone, but for some people, it is worrying because it's worrying like this, right? Like I decide, like, I'm thirsty. I would like a sip of coffee. Here's my coffee. I'll take a sip. If epiphenomenalism is true, my intention to pick up the cup, my volition, my decision didn't play any causal role. It's an epiphenomenon. It's like the steam whistle on the locomotive or the phases of the moon. No causal role, only an effect. All effect, no cause. And that's spooky. Yes, Matthew, what's your question? While you're formulating your question, Matthew, I will answer Shannon's and Joshua's. So, okay, does this theory mention anything about mental states as a reaction to external stimuli? Well, which theory? Identity theory or epiphenomenalism? I would say not. It doesn't really say anything as Kim has presented it here, but yeah, like if on epiphenomenalism, mental states as a reaction to external, that is physical stimuli, would just be effects, but with no causal role to play. Um, and then on identity theory, everything would ultimately boil down to the physical anyway. So if somebody goes boo and you feel frightened, um, you're startled. Your startle response, your mental state is just identical with a physiological state, right? Yeah, like an emotion. I mean, emotions. I mean, I've got a. So I'm not an identity theorist, and again, personal opinion alert. But I also don't think I'm an epiphenomenalist. Um, Emotions evolved, consciousness evolved. um, Mental phenomena, I think, are real and have a role to play in the lives of organisms like us that have evolved, but not in the way that our experience of ourselves leads us to believe. Anyway, I'm not going to go any further down that rabbit hole. If you want to, though, just read Daniel Dennett. Like, I'm a big fan of Dennett. I think Dennett does a great job at this stuff. And if you want to know more about the kind of thing I'm talking about, just read some Dennett. In fact, we're going to be reading some Dennett later. So, okay. Joshua says, haven't there been studies where they found that your desire to do something happens just before you actually become aware of your decision? Yes. So it sounds to me like you're talking about Benjamin Liebei's studies on the readiness potential. I think I'll talk about this more when we talk about mental causation, like the chapter. But the basic idea is that Liebei knew about a type of kind of like brainwave thing that happened before we made simple intentional actions like flicking your wrist or flexing your wrist, right? It's called the readiness potential. It's a slow change in electrical potential that we can measure at the scalp with an EEG in the premotor and motor areas. And Libe wanted to know what comes first, your conscious intention to move or the readiness potential. And so he measured the movement by hooking up myoelectric sensors to your wrist. It's easy to measure. We all know the movement is going to come last. He measured the readiness potential with an EEG. electroencephalogram. And then he measured the conscious intention to move by having people report when they were basically doing like a clock monitoring task to report when, it's a little dot moving around an oscilloscope. They had to report where the dot was when they felt the intention to move. And then he had to do lots of trials and sort of average everything out and calculate what happened when. And the readiness potential came before the conscious intention to move. So it's kind of spooky. But Libe also noticed that some participants experienced an urge to move and then decided not to. And so he'd see like a readiness potential start to emerge and then go away. And Libe reasoned that there's actually a conscious veto mechanism at play here. I like the way that Richard Gregory, the British psychologist, put it. He wrote that we do not have free will, but we do have free won't. And that's a clever way of putting it, but it also accords with what we know about the brain. The brain is always preparing motor plans for interacting with our environment, but a lot of them get inhibited. So, yeah, maybe we don't have free will, but we have free won't. Um, Maybe we'll say more about that when we talk about mental causation, as I said. Okay, Matthew's question. Does the decision making process really happen only mentally if you need to decide based on parts of your brain? If I have a water and a Coke next to me, next to each other at a restaurant, I'm still choosing to make a decision between the two based on my preferences and how my mouth feels. But these things are from the matter in my brain and responsible for my memories and what neurons light up and make me happy drinking a nice drink. Yeah. So maybe you take the Coke and you think, I decide to take the Coke because I like the Coke better. But that's because, Coke makes those neurons fire better than the water does, such that you find the Coke more refreshing and more satisfying. And some people would say that that's epiphenomenalism. You don't have free will. And some people would say, like, well, I mean, even if your reasons for acting are determined by biology or your upbringing or genetics or whatever, they're still your reasons and not someone else's. So you still did make that decision. Um, Make sense? I mean, again, this is like a whole big rabbit hole we're going down. Um, which I think I'd like to save because Kim, in the chapter on mental causation, like Kim talks about epiphenomenalism a lot, and we can really get into the weeds. Um, Again, it's not really an empirical question. Like, do we have free will? I know that people like Libe have done studies on it. Another one is Daniel Wegner. You can take a look at his work on freedom of the will. There are empirical questions we can ask of will and volition and intentional action, but the question, do we have free will, is actually like a philosophical question. It's a metaphysical question. It's not something you can do an experiment and answer. The answer depends on what we mean by free will, how we conceptualize free will. So that's why philosophy is important. I love science. I am a scientist. Okay, I actually am. My PhD is in cognitive science. I am happy as a philosopher and as a scientist. We do not need to be enemies. But one of the things I've learned is that there are scientific questions and there are philosophical questions. And I think sometimes scientists and philosophers kind of get into each other's lanes, and it doesn't always go well. We have to remember philosophical questions need philosophical answers, scientific questions need scientific answers. But when we work together through the power of friendship, philosophy and science can help us really expand our understanding of ourselves and the universe. So, sorry, that was a big old digression. Let's get back on track. We're going to talk about some arguments against mind brain identity now. And Kim actually gives us three of these. The epistemological, a couple of, well, there's three groups, I'll say. There's a few epistemological arguments, there's a modal argument, and there's an argument for multiple realization. We're only going to look at the last one. So if you read all of this part of the chapter, great. But I'm going to focus on multiple realization because this is going to serve as a nice segue into the next topic, which is machine functionalism, which we'll look at next week after I've given the essay instructions on Wednesday. Okay, so on page 121, Kim says the psychoneural identity theory says that pain is C fiber excitation. But that implies that unless an organism has C fibers, it cannot have pain. But aren't there pain capable organisms like reptiles and mollusks with nervous systems very different from the human nervous system? Remember last time we were talking about the super Spartans and the super Stoics, and then we talked about animals with radically different physiologies? This is like that. There are animals with very different nervous systems than ours. And we agree that they feel pain. So there are animals with somewhat different nervous systems, like our dogs and our cats. They're mammals like us. Our brains are different, our nervous systems are different, but they're a lot more similar than they are different. But what about a very different sort of life form like an octopus, right? Um, maybe octopus don't have C fibers, right? Maybe they have something else like O fibers. But serious attention has been paid to the prospect that invertebrates like octopus and also crustaceans like lobsters, shrimp, crabs, serious attention has been given recently to the idea that these creatures are capable of feeling pain, even though their nervous systems are quite different from ours. Um, so I'll put the question to you. I mean, do you think that an octopus can experience pain, or a lobster, or anything like? We're talking not a mammal, not a bird, not a reptile, but something very different from us, like an invertebrate. Do we think they can experience pain? I take it for granted that you think our dogs and our cats can, right? And our birds and our reptiles and whatever little fur friends we have, or I guess not fur friends if it's reptiles, but well, okay, so yeah, Matthew, I'm glad you mentioned that. Lobsters don't actually scream. That's actually air escaping from their shells. So they're not like ah, like in pain. But I can imagine it's not fun to be boiled alive if you're a lobster. Um, so I don't think they don't scream, but it seems reasonable to me that they could experience pain, and that's why I actually do think that if you're, and again, this is my personal belief. You're welcome to disagree. But yeah, like Grant says, okay, so Grant, yeah, you worked at the keg and you had to dispatch the lobster before you boil them. I think that if you're going to eat a lobster, it's the ethical thing to do is to dispatch it before you drop it in the water. like, and you can do that. Well, you can find out on YouTube if you want to do that. I'm not going to tell you how to dispatch a lobster here. Um, or I grew up in northern Ontario. I'm up in northern Ontario right now, and there's a big fishing hunting community here. I don't hunt. I never have. I don't. It doesn't appeal to me. I always say if I'm going to shoot an animal, it will be with my camera, not a gun. But I do like fishing. I remember growing up, the older generation, if we caught fish and we would have a fish fry, they would just start filleting the fish alive. And I was always just like horrified by that prospect. Like, oh, you can't do that. You have to dispatch the fish first. So I think fish are vertebrates, but I think fish feel pain. And so, I mean, I don't really eat fish that I catch. I let them go and continue to be fish. But if I were to eat a fish, I would absolutely try and I would dispatch it before I started filleting it. Yeah, they would say, Shannon, very similar. Uh, But, there are methods to ethically dispatch a fish. There's a Japanese method called ikejime, which you can look up. I think that's if again, if you're going to eat a fish that you've caught, I think the ethical thing to do is dispatch it before you do it. Sure, there's an argument that maybe it's not ethical at all. Maybe we should all be vegetarians or vegans. I don't know. I'm just saying, if you're going to eat a fish or a lobster, you should try and cause it as little pain as possible. Right? So, look, I think we're all on the same page here. Now, lobsters, octopus, fish, they all have very different physiologies than we do. Maybe they don't have C fibers. Does that mean they don't feel pain? I don't think so. It's also conceivable that there are aliens with very different physiologies than we have. I think it would be absurd to deny that such a creature could not feel pain. I mentioned that movie, Project Hail Mary. I want to read the book now that I've seen the movie, but I saw the movie a few weeks ago. Who's seen it? And there's Rocky the alien, and he's like really different. Oh, the movie's better. Oh, interesting. Oh, I'll have to compare it with the book, but I really like the movie, and I'm not even a Ryan Gosling fan. Um, but Rocky the alien, he's got a very different physiology. Cole's got the book. We'll watch movie. I think you'll like the movie. I don't mind if books are different from movies or vice versa. I don't care. Um, but the point is that Rocky is well, he's like made of rocks, basically. He's got a very different physiology. Um, Lives in a much different environment than we do. But I think whether you read the book or saw the movie, where Rocky has to go into Grace's atmosphere to save him. Uh, when I was watching that part of the movie and Rocky was getting all oxidized, I was like, oh God, even though it's just a puppet, I'm imagining this creature experiencing something equivalent to pain, even though he's a very different sort of life form than we are, right? Maybe we could even make a robot and make it experience pain by programming it the right way. Go back to Daniel Dennett, who actually wrote an interesting paper on this called "Why You Can't Make a Computer That Feels Pain." And the reason why, according to Dennett, is that we don't have a good enough theory of pain. Nobody can really decide what it is. So there's no way we can implement it in a robot. But imagine that we solved that problem. Perhaps we could make a robot that would experience pain. I always think of that clip from the episode of The Simpsons. Lisa the skeptic. She's Lisa Simpson discovers they're going to build a mall or something. They're going to build something, and but Lisa discovers bones. So it becomes like an archaeological site, and she takes one of the bones to Stephen Jay Gould, and then it's like an angel skeleton, and it becomes this whole thing where everyone thinks it's an angel, but Lisa doesn't. Yeah, and Stephen Jay Gould is the guest star, which I thought was cool. Anyway, the town riots, burns down a bunch of museums and research institutes. They burn down the Springfield Institute on Robotics, and out comes a robot on fire, like screaming, like, "Why was I programmed to feel pain?" um, yeah, I have not read this. I have no mouth, but I must scream. But I should read it. I know it's Harlan Ellison, and I'm a big fan of Babylon 5. And Harlan Ellison was the creative consultant on Babylon 5. So I guess I'll have to check it out. So I'll check that out. But you get the idea, right? The idea here is that creatures with different physiologies than us, or even artificial creatures, might experience pain. And this is the idea of multiple realizability. Ah, interesting. Yeah, that's dark. I'm really gonna have to read that. Okay. Um, So this idea of multiple realizability. Actually, I'll just go back to the slide. The argument of multiple realizability basically is saying that um, pain is multiply realizable. So an identity statement like pain equals C fiber stimulation must be false because there are creatures that don't have C fibers, or there are conceivable creatures that could not have C fibers, and all of these creatures could still experience pain. So um, pain is multiply realizable. It can be realized in different physical substrates. To illustrate multiple realizability, think of a calculator. This is my favorite example. Anybody got a calculator kicking around? I have one on my phone. I'll just open it. It's an app. So let's open my calculator app. It's the same one you have if you have an Android phone, I suppose. So that's what we'll call a software calculator or a virtual calculator. But if you went through public school or Catholic school or homeschool or whatever kind of school, you probably used a different kind of calculator. What kind of calculator did you use? Did you use a calculator that was made out of hardware? Ah, the Texas Instruments. The good old TI-84. Yeah. I even remember those graphing calculators. Remember those? Those are sick. Um, But whether you're talking about graphing calculator or your Texas Instruments stuff, or even one of those little pocket calculators with a little solar panel on it and everything, that's a different way to realize a calculator. That calculator is realized with like a circuit board and buttons, and there are little circuits and pathways and stuff on the board. So that's like a hardware calculator. This calculator isn't like that. It is software that's run on my phone. Same with the calculator on my computer. What are some other ways to realize a calculator? We've got the examples we're familiar with, our little quotidian examples: smartphones, computers with calculators, pocket calculators, graphing calculators. What other kinds of calculating machines have there been? Your fingers, yeah. I can calculate. What's 3 plus 2? It's 5. Damn. Calculator. Yes, an abacus. That's one that I was looking for. Um, you know, the Romans, for example, they used the abacus. They didn't have pocket calculators, but they could pull out their abacus and do real big calculations. There are really, really cool abacus from like ancient China, from Japan. We see versions of the abacus all over the world, right? And they're another way to realize a calculator. So this is multiple realizability. Um, the mind might be the same. There might be more than one. So just as in the same way, there's more than one way to realize an arithmetical operation like 2 plus 2 equals 4. You could do it on an abacus, a pocket calculator, a software calculator, maybe a slide rule. Right? I could go on. Your fingers. There's more than one way to realize that mathematical operation. Maybe there's more than one way to realize a mental state, like pain. That's what multiple realizability says. And this is related to functionalism, which is the idea that um, that what makes something mental, a mental state, what defines that mental state as the mental state that it is the functional role it plays within the system, not the physical realization. And we're going to examine this more next week. But just know that for now, that functionalism is due largely to Hilary Putnam, who was a philosopher and mathematician. Um, and Putnam based much of his work on functionalism on Alan Turing and his notion of the Turing machine. Um, so functionalism is probably the dominant paradigm in philosophy of mind and has been since the decline of identity theory. It is, in fact, the reason why type physicalism or type identity theory went out of fashion. So again, mental states are functional states. The type identity theorists or the type physicalists, like Smart, said that each mental event or each mental state is a type of brain state. But that can't work because of multiple realizability. So maybe token identity statements work instead. And multiple realizability allows this. So um, token physicalism or functionalism is fine. But type physicalism or identity theory doesn't really work because we can't all be having the same type of brain state. My brain is wired up different than yours. My dog's brain is certainly wired up very differently than mine or yours. Octopus have a weird distributed brain that goes through their entire body. Um, so there, the octopus being in pain, that cannot be identical with the same physical state that I have when I'm in pain. So that's the difference. So if you want to be an identity theorist of some flavor, you've got to give up type physicalism for token physicalism. So type physicalism is reductive. It reduces kinds of mental states to kinds of physical states, and it thereby eliminates the mental states. Token physicalism says that the pain that I'm having right now is a neural event, but it could be otherwise. The octopus's pain is going to be a different sort of neural event. The robot's pain or the alien's pain is a different neural event. Make sense? I just mainly, when I ask if this makes sense, I want to make sure you're clear on what the word type and token mean here. So type is like a kind of thing, and a token is a particular example of that thing. So type physicalism implies that we all have the same kind or type of brain state, which can't really be possible because of the way brains work. It's like, um, if I say we all have the same type of car, maybe we all have a Honda Civic. What we actually have is tokens of that type. Your Honda Civic is blue, mine is gray. Yours is newer, mine's older, right? Just for example. So we all have different tokens of the same type of thing. That's what it means. So the pain I have right now, sure, that's identical with a token of a neural event that is pain. Um, but octopus pain, alien pain, robot pain would all be different types, would all be realized differently in terms of their physical realization, is what I mean. So Kim explains the most widely accepted form of physicalism today combines substance physicalism with property dualism. All concrete individual things in this world are physical, but complex physical systems can, and sometimes do, exhibit properties that are not reducible to lower level physical properties. Among these irreducible properties are, most notably, psychological properties, including those investigated in the psychological and cognitive sciences. Um, so we're all some flavor or another of physicalist, most of us. Kind of, Grant. Yeah, like the form might be like the type, and then the objects in the world might be tokens of that type. Although I think it actually accords more with Aristotle's description of universals and particulars than it does form. I mean, Plato's forms, if they existed, would be universals. Um, but I just think Aristotle does it without all the weird Platonic mysticism. Yeah, so yeah, Storm. So could we go more broad? Like we all have gas cars, but you have a Honda and I have Toyota. Yeah, well, I guess what I'm trying to illustrate is that a type is like a universal or a kind. And then there are tokens of that type. Like this is a type of coffee mug that I have here at my in-laws. And you can get this mug at like any Tim Hortons. But like this one is the one I have and yours is the one you have. So this is a token of this type. Type identity theory would say that we all have the same type of mental state, but those kinds of identity statements don't work. Because obviously, my pain is my mental event and your pain is your mental event. So we have token physicalism, not type physicalism. And functionalism is a variety of that. Most of us are functionalists nowadays. Then you have your supervenience physicalists, right? They say that the physical world is what is fundamental, but there's a close and indispensable relationship between physical states and mental states. So mental states supervene on the physical states. Realization physicalists say that these non-reducible mental states are nonetheless physically realized or physically implemented. So supervenience physicalists still think it's in a certain sense over and above, but there is this close relationship, whereas the realization physicalists say that the mental is, while non-reducible, is physically realized. It's a subtle difference. Our non-reductive physicalists, so not our identity theorists, are also mental realists. They think that mental states are real things. They either supervene or are physically realized by the brain, but they are nonetheless real. Here are some further claims of non-reductive physicalism. So substance physicalism, okay, the space-time world consists of bits of matter, they're aggregates, other physical stuff, force fields, electromagnetism, gravity, etc. The irreducibility of the mental properties are not reducible to physical properties. Mind-body supervenience or realization, either the mental properties supervene on physical properties, or B, mental properties, when they are realized by physical properties. And mental causal efficacy, mental properties actually are causally efficacious. Mental events are sometimes causes of other events, both physical and mental. So these non-reductive physicalists, importantly, are not epiphenomenalists. So that's important to keep in mind. And you can take a look in Kim, which of these sort of principles the supervenience physicalist would adopt and which the realization physicalist would adopt. Um, that is it. That's it for today. So next time on Wednesday, it's going to be an instructional lecture, and I'm going to give you the instructions for your essay proposals and for the final essays. Now we still have time for questions. Are there any questions about what we've covered today? Because I realize I talk very fast, and sometimes maybe I explain things a little too quickly before they've really stuck. So, are there any questions before we wrap up? It's okay if there are. You've got me for another 15 minutes, technically. Maybe no one does. We can stop now. That's
Actually,
fine. Somebody was speaking there.
yes.
Sorry.
Sorry, no. What are the placebo effects?
Yeah, you know what? So I was going to mention this when we talk more about epiphenomenalism, but um, the placebo effect seems to pose a problem for the epiphenomenalists, right? Because if I've believed that I took the medicine and I feel better, but I didn't actually take the medicine, and nonetheless I feel better, that seems to imply that a mental state has affected at least another mental state and possibly a physical state. So yeah, the placebo effect would seem to pose a problem for the epiphenomenalist, but I think that anyone who claim any non-reductive physicalist would be okay with with that because they think that mental properties again are causally efficacious. So if I take the sugar pill when I believe I've taken an aspirin and my headache goes away, that is that sure seems like a mental state causing another mental state, namely my headache to go away, and maybe it even has physical effects. This is what athletes talk about. Mind over matter. Um, sometimes you're just having an off day. Um, so yeah, that's what I have to say about the placebo effect. That's a good question. Any other questions?
Professor?
Hmm.
Oh, for the essay proposal, is there like some guideline on how we can go about choosing the topic, or maybe it's the exact same as the reflection? Like,
Yeah, I think that after I go over the instructions, I thought that maybe what we could do is try and come up with a list of possible topics together.
next week, right? Okay.
Yeah. So it'll be like a little group brainstorming session at the toward not at the end, but toward the end of Wednesday's lecture.
I'm guessing though that you probably don't want everyone to write the same thing or write on the same thing.
I don't mind. Actually, if a
Oh,
lot of
okay.
you do write on the same topic, that might make things a little easier for Jack and I, but
Okay.
I certainly don't want to limit you to doing that.
All
So,
right.
then again, this is the whole idea behind the proposal, right? The proposal is
Mhm.
to make sure that you're going on the right track.
Mhm.
Yeah,
Right. And I guess hopefully it would be something related to one of the topics we covered in class.
totally.
Yeah.
That would be
Okay.
my preference.
Yeah.
If you can relate it to one of the theories of the mental that we look
Ideal.
at, or to consciousness, or
Mhm.
yeah, there's a lot of possibilities. Like we'll
Mhm.
talk about it, but you'll see there's a lot of possibilities for your essay topics.
All right. Great. Thank you.
No problem. All right. Um, Anything else? I guess not. Well, if there aren't any other questions, either about the essays or about today's material, I guess we'll wrap it up. I see that people are leaving. We've gone from like 23 to 16 participants, so everybody's going away to enjoy the rest of the day, and that's fine. I guess if you think of a question after, send me an email, or again, if you think it would be beneficial to ask and have it answered in front of others, use the Discord server. Otherwise, I will see you all on Wednesday, and I'll tell you all about what I expect for the proposals and for the final essays. So, thanks everybody, and have a good rest of your day.
Thank you. See you next time. Have a nice day.
Thanks. You too. Bye for now.